What do all acids have in common? As we have studied earlier, acids react with metals to form hydrogen gas. So, it is obvious that hydrogen is present in all acids. All acids contain hydrogen. The hydrogen present in the acid is such that when acid is dissolved in water, it separates out as positively charged hydrogen ions and enters the solution as hydrogen aqueous ions, H plus ions. We can now define an acid on the basis of hydrogen ions like it is a substance which dissociates on dissolving in water to produce hydrogen ions. Take the example of hydrochloric acid, the aqueous solution. It will dissociate into H plus, which is hydrogen ion, and chloride ion. Chloride is negatively charged and H plus is positively charged. In the presence of hydrogen ions, the hydrochloric acid solution which makes behave like acid. We have to check one more thing. The H plus ion thus formed will attach with H2O molecule and it make it polar molecule and it will become hydronium ion H3O plus. This is known as hydronium ion. Hydronium ion. So hydronium ion is H3O positive. Hydrogen dissociated from acid will make a polar molecule of water and join with that and form H3O positive. A common thing that an acid is having is it produces hydrogen ions when dissolved in water. Let us take these examples. HCl, which we have referred earlier, it will form H plus ions and chloride ions minus Cl minus ions. H2SO4, that is sulfuric acid, will form 2 H plus ions and 2 sulfate ions. Sulfate is SO4 2 minus. Nitric acid HNO3 gives H plus ions and nitrate ions. And acetic acid CH3 COOH, otherwise we can say C2H4O2, is providing CH3COO minus acetate ion and H plus ion. And you know now that the substance which is having hydrogen atom is an acid. But is all compound containing hydrogen an acid? We have studied that acid is a good conductor of electricity in the early classes. Now let us check. Take the solution of hydrochloric acid and glucose. Hydrochloric acid and glucose. Fix two iron nails on the rubber cork and place the cork in the beaker as shown in this one. Here also take one more and put it in the next week. Connect the nails with a battery through a switch and a bulb. This is the battery. Pour some dilute hydrochloric acid in the first one and glucose solution in the second one. On pouring hydrochloric acid, it will start glowing. Which one start glowing? In the nails connected with the bulb and switch and battery in the dilute hydrochloric acid solution is starting glowing. And what about this one? This is not start glowing. This shows that the acid conduct electricity. This is not conduct electricity. It is conducting electricity because the polarization the solution. And all material which are containing hydrogen is no acid, and hydrogen containing compounds like glucose and alcohol are not categorized as acids because they do not dissolve in water to produce hydrogen ions. The presence of hydrogen ions making this solution as polar one, and it is conducting electricity. As does not show acidic behavior in the absence of water. The acidic behavior of acid is due to the presence of hydrogen ions. The acids produce hydrogen ions only in presence of water. So in the absence of water, the substance will not form hydrogen ions and hence will not show any acid character. Now take this example. Take 1 gram of solid sodium chloride here. In this boiling tube, and add some concentrated sulfuric acid in this one. Little carefully. You have to pour it little carefully. Now fit a rubber core containing a glass delivery tube here. After the reaction of sodium chloride and what? Sulfuric acid. What will be formed? NaCl plus H2SO4, that gives Na2SO4 plus HCl. What about that? Now check for the balancing of this equation. How to balance this equation? NaCl. Na, how many Na here? Only 1, and here is 2. So we have to put 2 here, and Na is satisfied. And chlorine, 2 chlorine here. It is common for chlorine also, and 2 chlorine here, and this is only 1. So you have to put 2 here. So 2 chlorine, that is also satisfied. H2, how many H2 hydrogen atom? 2 hydrogen atom, and 2 is common for this also. So it is satisfied. And 1 SO4 here and 1 SO4 here. That is the equation is here. What is formed? HCl is formed. Hydrochloric acid is formed, but it is HCl, hydrogen chloride, we can say. That's the gas. So hydrogen chloride gas is formed, and keep a dry blue litmus in the mouth of this glass delivery tube. Then it will not having any color change. The possibility was, if an acid is exposed in blue litmus, then the blue litmus will change its color to red, and here is not having any color change. Now make somewhat moist here in the blue litmus. We have to keep a moist litmus, and wet, you can say wet litmus, and it is when it is kept in the mouth of the delivery tube containing what? The hydrogen chloride gas, then it will become red in color. The blue litmus will become red in color. It is not dry, it is moist one, and it will become red in color. So dry HCl gas do not contain any hydrogen ion in it, so it does not show acidic behavior. In fact, dry HCl gas, hydrogen chloride gas, does not change the color of dry blue litmus paper because it has no hydrogen ion in it. However, when hydrogen chloride gas dissolves in water, it forms hydrogen ions and hence shows acidic behavior like this. HCl, when dissolves in water, it will form H plus and chloride minus ions. This is the test to prove that thing. Now we will learn about the strong and weak acids. So we have to conclude that acids do not show acidic behavior in absence of water, which we have tested earlier. An acid is completely ionized in water and thus produces large amount of hydrogen ions is called strong acid. So strong acid is that acid which completely ionized in water and thus produces a large amount of hydrogen ions is called strong acid. We have to denote that HCl gives H plus Cl minus ions. This single arrow is showing that it is completely ionized in the form of ions. Sulfuric acid, nitric acid, whatever strong acid you will take, it will show like single arrow. It react very rapidly with other substances like metals. Rapid reaction, that's also a categorization of the strong acid. Rapid reaction with what? Metals, forming hydrogen gas, metal carbonates, metal hydrogen carbonates, metal hydrogen carbonate. These are the peculiarity of strong acids. And what about weak acids? Weak acids are partially ionized. What is that? Partially ionized. Well, only a part of that is ionized. When we consider CH3COOH, that is acetic acid. Acetic acid, when dissolved in water, that will form CH3COO minus plus H plus. This is a equation to denote the ionization of this. But it has not been shown like single arrow. It is a double-headed arrow like this. Means an acid which is partially ionized in water and thus produces a small amount of hydrogen gas is called weak acid, that we have told earlier. The double arrow pointing towards right and the left, in the reactant side and the product side, we have to say that the acetic acid does not ionize fully to form hydrogen ions. Carbonic acid is also like that. Sulfurous acid also a weak acid. Formic acid is also like that. It has a slow reaction. It is having slow reaction with substances like metals, which we have referred earlier for the strong acid. Metals, slow reaction. Metals, metal carbonates, metal hydrogen carbonates. These are the peculiarity of strong acids and weak acids. Strong acid is completely ionized in the solution and it is denoted as a single arrow, and it is having rapid reaction with metals, metal carbonates and metal hydrogen carbonates. Weak acids are only partially ionized, or we can say we will denote that with a double-headed arrow, that is only partially ionized. Slow reaction with metals, metal carbonates and metal hydrogen carbonates. These are the peculiarity of a weak acid. And now we have learned the peculiarity of an acid or the properties of acid, but we have to find what are the uses of mineral acids in the industry. Sulfuric acid H2SO4 is used for the manufacture of fertilizers manufacture of fertilizers, ammonia sulfate, paints, dyes, chemicals, plastic, and car batteries. Sulfuric acid is used to manufacture fertilizers, ammonium sulfate, paints, dyes, chemicals, plastics, and car batteries. Now it is the turn of nitric acid. Nitric acid is HNO3. HNO3. HNO3 is used for making fertilizers, ammonium nitrate, trinitrotoluene, that is an explosive. TNT we will denote like that. Trinitrotoluene, dyes, and plastics. Now it is the turn of hydrochloric acid, HCl. Hydrochloric acid is used for removing oxide film from steel before galvanizing. Galvanizing is a protection of the steel. How to protect that steel? We will study that. To remove oxide film from the steel before galvanization. Next is, it is used for dye making, textile industry, food and leather industry. That is the uses of strong acids in the industries.